All right, Physics 11 H'ers. I owe you a quick video on video 3, kinematics video 3. It's going to be on velocity versus time graphs really quick. We're already doing this on worksheet 2 with problems 11 and 12, 10, 11, 12. But I just want to give you a couple notes here so you know what's going on here. So let's just look at a little bit different of an example. Let's say we have a velocity versus time graph. Actually, let me write that a little better. Velocity versus time graph, and so time is in seconds, velocity is in meters per second. All right. Let's say it's a positive 5 meters per second, and then it goes down to negative 2 meters per second. So it's a little small, I guess you can see it. Let's say it's a total of 4 seconds, and then this is 10 seconds. So there's quite a few things we can know about this, right? We know it starts off moving in the positive direction, right? It's a positive constant velocity of 5 meters per second, and then it turns around, and it ends up with a negative velocity. So if I was to draw a motion map of this, I'll draw this a little bit bigger so you can see it. All right, let's say it starts off at a position of 0. It would move 5 meters per second for 4 seconds. So 1, 2, 3, 4. So each of those arrows represents a velocity of 5 meters per second. So if it goes 5 meters every second, that would be 5, 10, 15. Goes out 20 meters, right? And it turns around and it goes backwards at 2 meters per second for 6 seconds. 2 meters per second is going to be a shorter arrow. 1, 2, 3, 4, 5, 6. So 2 meters per second for 6 seconds, that would mean it would move about 12 meters, right? So that's just kind of mental math there. Meters, 2 meters per second, so 2 meters every second for 6 seconds, that would be a total of 12 meters. So going out 20 goes back 12, so that means it ended up at like 8 meters, right? You could just kind of think through it that way, or you can use the graph here, right? Area under the curve is velocity, so that, or change in position or displacement. So the area under v versus, and sometimes I try to make that velocity v a little bit different, like I do the position x. V versus t is delta x, which is, we call this change in position, which is also defined as displacement. Now, am I going off the board there? Yeah, terrible handwriting. Change in position or displacement is delta x. So, for the first 4 seconds, delta x is the area under this curve. It's the base times height. It's the base times height for the first 4 seconds. So that's delta x from 0 to 4 seconds is 4 seconds wide times positive 5 meters per second tall equals positive 20 meters, right? Then for the second half of the motion here, the area under the curve is indeed negative. It's okay. You can have a negative area under the curve. That means you're moving backwards.
Good morning. Please stand. Let us remember that we are in the holy presence of God. In the name of the Father, and the Son.
All right. Delta x equals base times height here. All right. So we've got delta x equals 6 seconds times negative 2 meters per second. Delta x is negative 12 meters. Sorry for the announcements. Forgot to make this video last night. Wanted to get it out to you this morning. All right, 12 meters, negative 12 meters is the displacement for the second part of the motion right here, all right? So forward 20, backwards 12. If you want to find the net displacement, so I have space down here, yeah. The total displacement from 0 to 10 seconds, 0 to 10 seconds is the sum of both of these. It's the sum of both of those. So it is positive 20 meters minus 12 meters, and it's going to equal 8 meters, positive 8 meters total net displacement. Total net displacement of positive 8 meters. All right, so this is kind of an experiment, this video. Probably went a little bit too fast with the writing. But again, the general idea here is that the area under the velocity versus time graph, right here, base times height, gives us displacement, and that can be negative. It's okay for that to be negative. That just means it's moving backwards, or it's heading in the negative direction, right? We usually say positive directions to the right, negative directions to the left. All right, it just means it's moving to the left. Oftentimes on the regions, positive is east, negative is west. Positive is north, negative is south. That's kind of also another way you could think of it. All right, so that should help you with those worksheets. Cross-hatching, if you're working on that one, again, it just means you're shading in the area under the curve. It's just a way to visually do that. All right. One thing they might add to this real quick before the bell rings in a minute is to draw the corresponding position versus time graph, right? Corresponding position versus time graph, let's draw it over here. All right, 10 seconds, changes at 4 seconds. So, all right, it gets out to 20 meters, and then it comes back quite a bit. It ends at 8 meters. So that would be your position versus time graph, right? Starts at 0, gains 20 meters, comes back 12 meters. Okay, that's the corresponding position versus time. It changes from a positive slope, a positive constant velocity, to a negative constant velocity at that 4-second mark. I'll leave it there. Video 3. Talk to you later.